Okay, so today we'll be doing some Leetcode because, you know, I need a job. But today we'll be doing Koko eating bananas, which happens to be, I think, a binary search algorithm according to Leetcode. Um, as you can see, I have been struggling because I thought that the the naive implementation would be easy to do, and then from there I could I don't know, see some kind of pattern or something, which I think is the way you're supposed to do it. I'm not really used to doing it that way, and in some cases the naive implementation is harder to actually do, so I just like skip it usually and try and get the right solution immediately. I also haven't done Leetcode in a bit, so we're close to finals. I'm trying to finish up all my work and start studying for that. But today I've remembered that I'm currently unemployed and need a software engineering job, preferably. So we will do this. Koko eating bananas. You're given an integer array piles where the piles at I is the number of bananas in the ith pile, and an integer h which represents the number of hours you have to eat all the bananas. You may decide your bananas per hour eating rate of k. Each hour, you may choose a pile of bananas and eat k bananas from that pile. If the pile has less than k bananas, you may finish eating the pile, but you'll just be lazy and not move on. So return the minimum integer k such that you can eat all the bananas within h hours. So I guess we should just write down the facts. They are: we decide and return k, which happens to be the bananas per hour eating rate. Piles. Piles is, I can imagine them as a bunch of bananas. I don't know if that's spelled correctly. Bananas, whatever. Piles at I is a bunch of bananas that takes minimum 1 hour to eat. What else did they say? Must eat all bananas in piles in h time or less, I would say. So you may finish eating the pile, but you cannot eat from another pile in the same hour. Yeah, okay. So I don't know. What I would do is let's try the naive solution again, because I'm not seeing any opportunity for binary search. What is the naive solution? So basically, every hour we choose so we have k, we'll make that equal to 1. We want a loop that, so this is, I'm going to say that while time taken is equal to 0, while the time taken is larger than while the time taken... Oh, okay. Okay. No. I don't have anything solved. So while the time taken is larger than h, we want to increment k. And then, while the time taken is greater than k, we're going to make time taken equal 0, and then for the index and the number, numbers too vague. I'm gonna say I and v for value. In enumerate, piles. I'll say pile time. Pile time is equal to, k. I guess it would be the value divided by k, but like I would say probably math dot max between 1 and this value, but this can't be a float, so I'll say math dot... What does ceiling do? Actually, I don't know if that's what I want it to do. Math.ceiling runs a number up to the nearest integer. Yeah, this is what I want, I think. Yeah, math.ceiling. So pile time is equal to is equal to the maximum. Well, actually, what's the point of having 1 here? It'll be always at least 1, right? There's no way there's going to be 0 items in the pile, I think. Leetcode, Koko. Yeah, I don't think so. So I'm going to delete that. Delete word, and then I'll just do like that. Whoops. So pile time is equal to math.ceiling at this. And then we can say maybe time taken plus equals pile time, and then we go through the list, So go through all the elements, calculate the pile time, and then add that pile time to the total time taken. And then basically at this point we'll say, alright, k increments. Actually, k should probably increment above. Oops, undo. And this should also be 0. So k starts by incrementing. Alright, so let's think about it like this. K is equal to 0. While time taken is greater than h. Does this even run? I don't think it does. This should actually be something really large. I'll probably say... Can I say... Is there a max function? Max integer in Python? That would make sense why the code wasn't printing before. No, this isn't it. I need a number to make this. I need this to be like... Oh, I can just say it's h plus 1. I'm trolling. Okay, so time taken will start as h plus 1. And then while the time taken is bigger than h, So that'll mean that it runs at least once. We can say k is plus or equal to 1. Yeah, so k becomes 1, and then time taken is equal to 0. And then we can count the number, the amount of time this takes. Yeah, I think this, and then we after want to return k, right? So let's see if this is good. Dude, no way! Let's go! This is only the naive solution, but I was getting sad that that it wasn't working before. Okay, so I have like a vague idea of how this works. How do we convert? Oh my god, I'm so happy it worked. It looks like it was first try, but like I tried to run this like 4 times before, which is pretty low. But like my morale is pretty low because I'm studying for finals, so you know, this is a win, man. This is a as Kai Cenat says, a W Riz Skibbity toilet win, you know? Alright, so I already looked at this hints, but I don't really get it. You should aim for a solution of O of n log m time. O of n log m. So n for going through the array, I assume. But what's the log m about? That's a binary. So like if we, I know that if we have like, you know, I've done data structures and algorithms, so I know that if you have a tree, to traverse a tree on average it's log n, right? Like to get from up here to down here, it's a search tree, particularly a binary search tree or any of its variants like a red black tree. But basically to get from the top to the bottom is log n time complexity. What's confusing me here is this is somehow log m time complexity and O of 1 space. O of 1 space, where n is the size. O of 1 space is also kind of crazy, which means we only work on the array and we use a few variables here and there. But you should aim for a solution with that time and that space where n is the size of the inputs of the inputs array and m is the maximum value in the array. Maximum value in the array. Okay, I'm gonna need another hint. Unfortunately, sorry. Given h is always greater than or equal to the length of piles. True. Can you determine the upper bound for the answer? How much time does it take Koko to eat a pile with X bananas? What? Given h is always greater than or equal to the length of piles, can you determine the upper bound for the answer? It'll always take Koko at least n hours to eat. Yeah, it'll always take Koko at least 10 hours to eat the bananas. I don't know how this is a hint. Hint 2. Bruh! It takes ceiling x times k to finish the x pile when Koko eats at a rate of k bananas per hour. Our task is to determine the minimum possible value of k. However, we must also ensure that at this rate, she can eat all the piles within the given h hours. Now think of the upper bound for k. The upper bound for k? The upper bound for k? I guess the upper bound is this, right? Like the ceiling? It's the max value. The ceiling is the max value in this thing. Are we cooking here? Wait. No, I don't see how this is binary search, though. If what I'm thinking is correct, then if we get the max value of the array, we have to traverse through it once, and that's O of n time complexity. And then no, I'm not understanding this, I don't think. Hint 3. The upper bound for k is the maximum size of all the piles. The upper bound for k is the maximum size of all the piles. That's literally what I said, no? Because if Koko eats the largest pile in 1 hour, then it is straightforward that she can eat any other pile in an hour only. Okay. And so then, in this case, what would k be? So like what they're saying here is that this tells us, oh, but like, isn't it kind of disingenuous to put this in binary search? I don't really get it, and it's not sorted. I don't see why the time complexity is O of n log m. Because then all we would really have to do here is say, you know, let's see, we're here. We found the largest element, which is 7. We need it to be less than 10. So, for that to be the case, if we can do this in an hour, then we can do these also in an hour. So that's 4 hours for this. But there's no need to eat that fast. So what? Could we divide or something by 2? So that instead of eating this in an hour, we eat this in 2 hours. Now, how do we eat this in 2 hours? Probably like, so in that first example, k was equal to 7. How do we eat this in 2 hours? Maybe divide by 2, so that, you know, we get like 4 or something. And then what? If this is 4, then we can eat this in, but then it depends on these too. I'm so confused. I don't really get it. This is not really a straightforward solution to me. Hint 4. Consider m to be the largest pile and n to be the number of piles. A brute force solution would be to linearly check all values from 1 to m and find the minimum possible value at which Koko can complete the task. Yeah, that's what I did. Can you think of a more no, bruh, that's why I'm looking at this. Perhaps an efficient searching algorithm could help. Okay, so you're telling me that you're sorting this, right? So you're saying something like piles.sort or something. Is it piles.sort or sort piles? Let me actually see. Is it piles.sort? Okay. K is equal to 0. Okay, I think it is. Okay, I'm going to keep the naive solution just so I can reference it. Binary search. More efficient method. O of n time. So we're trying to reduce this, right? I think I'm kind of picking up what you're putting down, my friend. My dear friend Leetcode. I think what you want me to do is piles.sort, so that now it's in order. And then what am I linearly doing here that I can do? What am I linearly doing here that I can do in log m time? Or what am I doing in m time that I could be doing in... It's not really m though, right? Oh, m is the minimum. So I guess it's this part of the loop here. So while the time taken is bigger than h, we just increment. Oh, I think I see. Actually, let me remove that stuff. So we sort the thing. Oh, so we start at the maximum value, and then I think I see. So let me see here. Instead of time taken, max int in list Python. Is this allowed? Yeah, just like that. Okay, so first of all, we have to find the maximum in the... Well, we can just make it time taken is equal to max max in our piles list. And then we sort the piles list. Actually, we can reduce the amount of operations taken just by sorting the piles in this order. And then we can just access time taken will be equal to piles at -1. Right? The last one, because it's sorted in ascending order. And then actually, wait a minute, am I just drunk? Maybe I don't need to sort it. Let me go back to my old solution and work from there. So the problem here with this solution is that it's too damn slow. This while loop goes from 1 to m, so that runs m times. And then this is n, because it just runs from the beginning to the end of the list. Basically, what I want to be doing with this loop instead is I want to start at m. So I want to start at the maximum value, not m. I want to start at the maximum value it could be, and then make my way down. So how I could do this is, sure, time taken can be +1, and then piles dot sorts. We don't really need to sort anything here. While time taken is bigger than h. I actually might not have to change this loop either, but instead of going up by 1, we need to do something a bit smarter. So we need to do something like k is equal to the maximum in piles. Okay, I think I see what the solution is. We do all this stuff. So k is the maximum, and then while the total time taken is bigger than h, which it will be for the first one, we say time taken is equal to 0, and then we go through and figure out the time, right? The time taken. I feel like now it's safe to put this all back into just one. So like, I'm gonna delete this word, select this word, paste it, and replace with a plus, so that we just add it in one go like that. This might be a lot easier to implement as a recursive solution, but let me thug it out and just do it iterative like a beast. So calculate the time taken, and then what, like half it? Oh, these conditions are kind of confusing me here. What's the hint? Give it to me. Give it to me! Rather than linearly scanning, we can use binary search. The upper bound of k is max, and since we're only dealing with positive values, the lower bound is 1. Okay, the search space of our binary search is 1 through max. This allows us to find the smallest key using binary search. Damn, but this is such a difficult thing to do. Actually, no, I can do this. I can do this. So, basically, here, I'm just trying to figure out the conditions of the binary search. Like, at what point should it stop? At what point should it, should it be like a left and a right pointer? Maybe. Actually, probably. I'll make k equal to the max piles. I'll probably have a left and a right pointer like this. Left, which is equal to 1. Right, which is equal to k. And time taken is that. All time taken is... I might actually have to change this as well. So I'll change this to be while left is less than right. Whoops. Undo. We get the mid. I'll just call it mid, which is equal to, okay, this is actually tricky because there was always something I would get wrong in this. I think it's left plus left plus right divided by 2. I think that's what it is. Right? Because if we imagine 2 pointers here, actually let's use our handy tool, Excalidraw. Whoops. So we have 0 to 8, say. This is our left pointer and this is our right pointer. We get the midpoint, so that would be, yeah, I think that formula is correct. But we get the midpoint, which is 4, and we add it to our left, which is 0. So 4 is our midpoint, and then our right becomes this one. Whoops. This becomes right. Mid is now. Oh, maybe that's not good. Okay, let's say we go here, because if it's 0, then it never changes. But if it's here, if we move our left pointer here, such that this is left, then this is now we need the midpoint between these two, which happens to be 6. Or wait, I did that wrong. It's right minus left, or am I trolling? Right minus left? I think so. Yeah, right minus left. Right minus left, which gives us 2. Divided by 2. Wait, no, right minus left is 4. Divided by 2, we get the midpoint. And then we add that to the left to get the current. Okay, I'm smoking. Don't know what's going on. But anyways, Instead of using K, we're gonna use mid. I think. Wait a minute. Okay, so all left is less than right. Mid is, we calculate the midpoint, and then we want to use that midpoint to figure out the time taken. And then we can say if then we don't need this anymore, but if time taken is bigger than h, then what? The time taken after we calculate how long it takes for that is bigger than h. We want to go smaller, and if we want to go smaller, then that means we have to move right to be equal to mid. Wait, smaller is, yeah, right, moving to mid minus 1, I think, right? Else it's left moving to mid plus 1. What's the use of K then? Should we just make K equal to mid then? I mean, yeah, let's make K equal to mid. I'll just do that here. K is equal to mid. Though this isn't very, actually, is this what we want to do? If the time taken is bigger than h, then we move the right. Otherwise, we move. Yeah, I think it is. I think this is indeed what we're trying to do. I don't know if it works, though. Oh, there is no left and right. I'll just do that. Do that. Run it. Oh. Wait, what? What? I'm a tad bit confused here. Huh? Your output was 3.75. How the fuck is that even possible? My output was 3.75? Oh. I'm a bit baffled that Python does this nonsense, to be honest. Should it just be integer division? I just can never tell. We're just not even close for this one. Ah, man. I feel like I'm not really understanding what's going on here. So this number represents our k. Oops. This number represents k. We start with left and right here. We find a midpoint. We check is the time taken larger than h. If the time taken is larger than h, then we want our new value to be, our new midpoint to be smaller. Our new k to, no! We want it to be bigger. Am I right? I feel like that's correct. Uh-oh. Never mind, I'm wrong. Oh, what did I do? The time exceeded for all of them? Damn, that's tough. Wait, what's going on here? If the time taken is bigger than, so if we're too slow, we want to increase our number. Okay, I see. I think I see. I think this is actually what we want to do. If the time taken is larger than h, so if we calculate how long it'll take and we're slower, if we're too slow, we want to speed up our numbers, so we move the left up so that we get a larger eating value. Otherwise we do this. I don't know if this is gonna work, but you know, we'll check. Oh wow, this is still, oh, we're close here. I'm guessing there's some sort of problem with our logic, I would say. Maybe we're supposed to this is always a problem. Okay, never mind. This is not a problem for this case. What? That's odd. I guess we don't want it to, I mean, how would it even handle this case? Wait, how does it handle the 2 pointers where they're the same? Like, what is the minimum or the mid? Let's see, if they're the same, then this is 0 and left, so it just becomes the current one. Interesting. Okay, there's a problem here, but I don't know what it is. Let's go through the code from the top. From the top, so we have k, we make it equal to our max piles. I'm not really sure why we do this anymore, to be completely honest with you. I think we're probably better off just like you know, replacing that. Left is 1, right is max piles, so the maximum number in our thing. We say while left pointer is less than or equal to the right pointer, the mid value. Dude, this what? Integer division. Integer division in Python. Okay, I'm settling this once and for all. We can perform floor division, integer division using this. It will divide the first argument by the second and round the result down to the nearest whole number. Is this what we want in this scenario? Round to the nearest whole number. It'll always round down to the nearest whole number. Let's say we divide something and it's 4.3. Is it better that it was 4? I think so. Yeah, I think so. And if we had something that was 15 and 4, is it better that it rounded down to 3? Let's say 15 and 2. Like, or I guess, what's a more reasonable example? 9 and 0. No. Yeah, 9 and 0. So we say 9 minus 0, which is 9, divided by integer division 2, which gives us 4, I guess. So, yeah, I think that's actually ideal. Because if it jumps straight to 5, there's a chance there, I don't know. I think that's correct. Let me actually double check this. Algorithm, binary search, algorithm. Yeah, so I know in Java that this is recursive. The iterative solution is left plus right divided by 2, while left is like that. But this is a search algorithm. So I have to figure out. It's probably not like it's not like due to the search that this is failing, I feel like. I'm gonna assume that the problem is here, because the reason I say this is we calculate mid, assign k to be mid, do all this stuff. If we have to call, if we run this again, if we run this again and, you know, or wait, maybe I should just put a conditional around it. At what point should we assign k? We should assign k we should assign k here. We should assign k in the case that the time taken is, you know, less than or equal to h up here. So we can just say, you know, k is equal to 0. But yeah, we should assign k every time. Yeah, I don't really know if it'll work, but we can see. Whoa, does it work? Yo, it works for real, and I didn't even need to watch Leetcode's video. Let's go! Alright, so you guys can also see what I do when I submit a Leetcode submission. I have a folder in Obsidian here for Leetcode. I have to hit Alt tilde. What the hell? Why is it not working? Maybe it's Shift tilde? No, there's no way. Shift tilde? Dude, I could have sworn it was Alt tilde. What happened? Is it because I switched? Oh, that might actually be it. All right, okay, we'll turn this into a setup my, because look at this. We've got, you know, for our Leetcodes, we have product of array except self. This is for study purposes when I want to look back and see how to solve certain problems. I can go through what I did to solve the problem, my approach, the time complexity of my answer, and the actual answer itself. And there's a plugin that I use, like an Obsidian thing that I use to help me do this, but I guess it's not set up or something. Or maybe I just forgot the binds. Let's see what it is. So I believe it was a community plugin, and or no, it wasn't. Okay, let's check this out. Leetcode Obsidian. Need help automating my Leetcode nodes using Obsidian. I believe this is probably where it is. No. Maybe there's a video that I watched. Oh my god, the internet's so slow. Somehow I can already tell that that's not the answer. Oh my god. Why is my internet being like this? Please tell me he tells.
Alright.
Yep.
So,
wait, nope.
A bit of a disclaimer before we get into the video. You've
okay, that's it. I've had enough.
Knowing the title. So
I'm gonna search in community plugins, browse, say Leetcode. No, it was something more general than that. Let's see. Editor, syntax highlight, period notes, space repetition, sub, timelines, underline. I guess not. I can't remember what it is. And I don't even have a name of it. Let me check inside my templates. Leetcode problem. This was the... But what was the actual thing that allowed me to automate writing Leetcode notes? Obsidian. Easy formatted Leetcode problems directly. Yep, I think it was this one. Yeah, it was this exact one, correct. So we gotta go here, and then he explains pretty well how to set it up. Create a new folder called scripts. Save leetcode.quickadd.js in the scripts folder, which I believe was here. I'll just quickly download it. Open the quick add. Okay, so first of all, I'll go to Obsidian, go to files, downloads. Where's the JS file? I could have sworn this was allowed. Oh yeah. So we'll just go downloads here then. Though I don't have the Obsidian path readily available, which is why I just wanted to drag and drop kind of thing. Oh, I guess I can do that. It says there's 2 files, but I can't see any of them, which is not a problem, I guess. Open the quick add plugin settings in Obsidian, create a new macro called user script. Quick add plugin. Do I even have something like that? Quick add? It might be a core plugin. Quick, yeah. Maybe here then? quick add. There we go. Leetcode import, it's a thing. So why is it not Leetcode importing? Did I mess up something or? Alright, whatever. Let's keep going. Select it as the script for this choice. So create a new macro and add a user script. User script, huh? I want to delete this since it's not working yet. User script. Is that like... What is it? New macro. User script. So... I'm a bit lost here. Okay, I'm deleting all this since it doesn't make any sense and it's not working anyhow, so it's probably the... So new macro, Leetcode import, add the macro. What? Configure. We said user script. Leetcode quick add. I don't really... That's weird. What else am I supposed to do? Select as the script for this choice. Okay. Then add a page template for your macro to use. Add a page template. Template path, so it'll be in templates and Leetcode. Oh my god, fuzzy finding's not a thing. File name format. I'm sure they'll ask anyhow, so I won't really change any of this stuff. If it already exists, sure, you can do that. It won't exist, but you know. Actually, just don't work. Do nothing. And open it. Okay. I think it makes sense. And then obviously the output should be yeah, put in a particular folder. It should be in Leetcode. Bro, why Leet? Oh, so okay, that's weird. We'll add that. Put it right there. Alright, I think that's good. I'll run it. Run unplug and reload. Wait, but it didn't. I can't see it. Or I guess that's a bit confusing, huh? It's weird. So how do I run it again? Oh, I didn't even set a bind for it. Let me think. So it should be in hotkeys. Quick add. Yeah, it says alt and that. But it's no good. Let me close and then try it again. Oh, what? Why did it come up twice? That's weird. Why? Oh, there's no way. Dude, why is this thing so hard to set up? The instructions are kind of shit, I'm not gonna lie. There's nothing worthwhile down here. Damn, and it was just working and then not. It's okay. I suppose there's a few things we can do to... I don't even know how I got this thing working. So I'm gonna create a new folder called scripts, just in home, or just in overview, I should say. Is it an overview? Yeah, I just want to create a new... Bro. There we go. Scripts. Is it scripts or script? I think it's script. Scripts. And save leetcode.quick-add. Alright, as long as it says that it's in there. Open the setting in Obsidian. Whoopsie daisies. What if I did everything correctly, but like, I just needed to do this? Yeah, it's not that. We're gonna do this, delete, like this, and then we'll just try again. So open the quick add. What is this called? Leetcode Polar Obsidian. Anyone else set this up?
Alright, so a bit of a disclaimer before we get into the video.
Why is it so slow?
You've
what is this?
clicked the video knowing the title. So you're there you
YouTube's been
go.
acting up recently.
And once you're done, you want to look at the solutions. And then you read about the solution. You know, just a synopsis. Here's the syntax for them. Here's the usage for them. Right? So that is done.
Okay, I've had enough.
And then I would, solve it.
I've seen enough. Is quick add enabled? I mean, it should be, right? Yeah, it's enabled. Maybe there's a problem with the hotkey. Maybe I should have tried that before. Well, it's okay. If I want to run quick add, let's change the bind to shift that thing. Is that actually something we need to do ever? Oh, it is something we need to do. Which is probably why it was alt. Oh, but alt is no good now, which is probably why I did that. Or why it wasn't working. Damn! I gotta do a... Oh my god. Let's see. What's something we won't ever be doing? Probably like this, right? This and this. This and this. This and this. Hello? Guess no. Doesn't... It's not good. Doesn't work either. What else can we do? That's... To be fair, though, the squiggly... Or no. Why can't I just use this thing? I guess because I use that too for code, right? Damn, this is hard, man. What are some cool hotkeys that we can use that aren't already in use? Add file property. I do not be using that, so let's say we'll use that. Control quick add. So run quick add. We can say control that. Cool. Now back to quick add. I'm gonna go here. Create a new macro and add a user script choice. New macro. Leetcode import. I don't know what that was. Hello? Okay, there we go. So now what? Wait, it's user script. Leetcode quick add. Add a user script choice. Select the Leetcode quick add.js as script for this choice. I don't know if we did that. I don't know what that is. I'm gonna leave that as is. Huh? I'm a bit confused about all this. Nope, not templates choice. Yes. Huh? Dude, okay, I'm starting to lose it. Okay, let's start again. This is mad. This is crazy, man. I don't know why it's so difficult to do. Yeah, that's indeed where my templates are stored. What does this do? What does that do? I don't know. Creates a copy. Solid. That's to delete. What is this? To move it. Macro manager. Why are there two here? I'm so confused. Okay, so in your Obsidian Vault. I want to read this. Okay. In your Obsidian Vault, create a new folder. Why did I delete the other one? I don't even know. Create a new folder named scripts if it doesn't already exist. Save in scripts. Open quick add. Create new macro and add user script choice. Create new macro. Let's just do that. Create new macro. So macro Leetcode import. Add choice, right? So now we have a macro. Now what? What? I thought... Okay, whatever. Not a big deal. Add a user script choice. Whoops. User script. Leetcode quick add. This isn't really the... Whatever. It's about the same. What? Wait, that's odd, though. I mean, I don't know. I guess maybe not. And then we add the choice, is what it said. Add a user script choice. Select the JS file as the script of this choice. Add a page template. Yeah. You just add a template and that's it. Okay. Leetcode. Oh, that was the one. I'm not gonna do that. File name format, not really my problem. Create in a certain folder though. Leetcode. I'll add that. That's pretty much what I'll do. And if I go here, it should be saved. Okay, looks good. So now if I go here, or I go here to manage macros, I don't want it to run on plugin load, I'll say. But yeah, it seems to have saved. And what did I say? It was control this? Yes, finally! Okay. Jesus Christ, how long did that take? It's gonna be so funny watching that back. What Leetcode question was that? Koko eating bananas. Bruh. That's so funny. Anyways, I get that thing for the Leetcode question. Go here, paste it in here. What Leetcode question is it? Because you can see I'm following a certain format where it's the Leetcode number and the name, so that way I can quickly just like reference by I can eyeball it to see. Bro, what? Oh, that's so cool. That's actually so cool. I don't know how I did that, but that's so cool. Control Shift T is what I meant to do, but I probably hit V or something. Leetcode question 875, Koko eating bananas. I don't want to have to type that again. You're kidding. You're actually kidding, dude. Jesus Christ. 875, huh? So 875, Koko eating bananas, like that. Did it put it in the right place? Yes, sir, it did. Yes, sir. Okay. So we'll go here. I have way too many things open that don't need to be open. Data, JavaScript can stay open. Computers, twice. Threesome, pause. Input and output variables, twice. Assignment 3, we're done with that. 875, huh? So yeah, everything's formatted as it should be. And I can say completed is true. I just used completed to remember if I was the one that solved it or if I needed help solving it. And in this case, we did not need Leetcode, which is good stuff. So intuition, whoops, undo. In this case, it helped to solve the problem using the naive solution. Basically, the naive solution is basically we iterate start at k equals to 1 for Koko's eating rate, and in one while loop set the Koko's eating rate starts at 1, and we set what do we call that one variable from the naive solution? Oh, I didn't submit the naive solution? Oh my god, what was I doing? That's terrible. I wonder if how far back this saves. I think this was it. Oh, damn. What is this? Bro, okay, wait, so... Okay, but this was the correct solution. Wait. Okay, so the code is... Yeah, I guess it would be too slow at this point. Anyways, so moving on. To be h plus 1, so that the initial test of the while loop of the outer while loop passes. Basically, the outer while loop dictates when we have found our solution, and it should continue running until we have found a K such that Koko finishes eating before the guard returns in, how long is that? H hours? It's H? Yeah. This is simple enough to implement. We need to all the items in the list, and we need to go through all the items in the list and determine if Koko finishes before the guard returns for every iteration of K. The optimized solution is pretty much the above solution, except instead of linearly searching through the list, we do, not searching through the list, searching for the value K, we search logarithmically. That is there really more to say than that? Not really. So basically, it looks like this. We can do so using binary search with 2 pointers. And searching until the right pointer is past the left pointer. Honestly, the rest is kind of like easy to figure out. I don't need to explain the solution that in depth. Let's see. Time complexity. So we have this outer loop, which runs in log m time, because m is the maximum. Log m time. So yeah, log m, and then this is log n, and then the rest is constant. So this runs in city is o n log m, where m is the largest element in the list, and n is the size of the list. Space complexity is constant from what I can see. Yeah. All right. And then lastly, I like to wait for the other ones. Let's see, valid product. Okay, I have the whole thing, like the whole class solution thing. Oh my god. Solution. And then what? Define min. I'm not typing all this shit out. Sorry. And then we say v. Cool. So I like to see if I can solve the solution again, just using my head as opposed to trying to remember what the solution was. So let's do that. We start by making k equal to 0, 1, I mean. And then we can, actually, doesn't matter. Doesn't matter what k is, genuinely. Not really. It can be 0, it can be 1, it could just be like a million. It doesn't matter. But anyways, L is equal to 1. Right is equal to the maximum of piles. And then we say something like while left is less than or equal to right, we can calculate mid, which is equal to left plus right, integer division 2. Is this solid? No, it's not solid. I'm wrong. This is supposed to be right, this is supposed to be negative, and this is supposed to be left. Everything else is good. From here, what we want to do is say for index, I don't really use the but like enumerate, it's just the easiest to do because you have access to the index and the value. So I'll do that. For I and v in enumerate piles, we say, I forgot one of these variables, which was it like total time taken or something? I guess it actually doesn't need to be up there as well. So we'll say time taken is equal to 0. Time taken plus or equals what did I say? Math dot ceiling of the numbers v divided by k. So it should be the maximum time. And so now we can say something like if the time taken is larger than h, if the time taken is larger than that, this means that she's too slow and we need to go faster. Pause. But what do we say here? We say horribles. Actually, wait a minute. I'm gonna make this maximum of. I'll make this equal to r as well. No. Anyways, if the time taken is bigger, then we're too slow, and what needs to happen? If we're too slow, we need to increase the speed at which we're eating. So that means speed has to increase, which means k has to increase. So if for k to increase, we want left to become mid plus 1. Is this solid? I think so. Mid plus 1. And then, if that's not the case, we want right to become mid minus 1. Yeah. And then we also want k to be set to mid, I want to say. Yeah, I think so, right? K is equal to mid. Yeah. Okay, and that is pretty much it, but we need to remember to return k. Whoops, undo. Yeah, let's see if that's correct. So we have L is equal to 1, we have right is equal to max piles. We have k is equal to 0, while left is that, time taken is equal to that. We get that, v divided by mid. Oh, that might be a bug, actually. Let's see. Yep, it is a bug. We don't want to do that. We're going to use the mid that we calculated. And then do that. And if the time is bigger than h, then left is equal to mid plus 1. Otherwise, k is equal to mid. And we do that. And then we return k. Yeah, looks good. Looks good. Anyways, that will be all. It's getting pretty late. Thank you for watching. See ya.